Hello beautiful people and welcome back to our today's tutorial. In today's tutorial, you're going to learn a lot of skills. Yes, a lot of skills. So ensure to stay through the end. Now let's look at this amazing equation we have for today. Is it something you can do? You can pause the video. Let's know your own answer in the comment section. If you can't, let me expose you to a lot of skills. But before you do that, what do we call this kind of equation? This kind of equation is called transcendental equation. Why? Because it involves polynomial. This is a polynomial. Just like when you have x squared. This is a polynomial of degree 9 because the highest power of x is 9. And this is degree 2, which we usually call the quadratic. Okay? Okay. Now this one is 3 to the power of x. This 3 to the power of x is not a polynomial. It's different from when you have x to the power of 3. Okay? This is a polynomial, but this is an exponential function. So you see, when you have exponential function and a polynomial joined together in an equation, we call such equation a transcendental equation. Now that you know what this is called, is it something you can do? Now let's do it together. It's very simple, okay? So we're going to begin with solution. The first thing is get the lowest common multiple of these two powers, which most people call the least common multiples, okay? And we abbreviate as LCM. So the LCM of the powers will be the product, which is 9x. Now what do we do with this? I'll show you. So we are going to bring this down and divide it by 9x, which is equal to x to the power of 9 divide it by 9x. We have not changed anything. Why? Because what we did to the left, we also did to the right. So in this case, we are still in order. Now in this case, this cancels 1, cancels 1. 9 cancels itself 1, cancels itself 1. So we are left with 3 to the power of 1 at the numerator. Here we have 9 because 9 multiplies 1 is 9. And here we have x. Here we have 1 over x multiplies 1 will give us x. So what do we do at this point? You have to think. Now what we do here is, if you look at this side of the equation, you will notice that here is x, the base, and the denominator of the power is also x. That means the two are the same. Now the question you ask yourself is, can I make this base and this denominator to be the same? Until you make these two to be the same, that is the only time this equation are equal to each other. So what do you do? Now let's see. Supposing we now say, let's raise this base to the power of 2. If we do that, we are going to have 3 raised to the power of 2 is 3 times 3 will give us 9. And you know, when you do to the base, you should do to the power. If not, it's not balanced. Okay? So let's do to the power. 1 over 9, you multiply by 1 over 2. Okay? So in that case, this multiplies 1, this multiplies will give us 18. So you see, it's not the same. Here we're having 9 as the base. Here we're having 1 over 18 as the power. So they are not the same. I take it off. Now let's try another. What if we have 3 to the power of 3? Let's see what it gives us. It is 3 multiplies 3 multiplies 3 to give us 27. Now for this power, we can have 1 over 9 multiplied by 1 over the same 3 we used here. 1 multiplies 1 is 1. This multiplies will give us 27. What did you observe? This is the base. This is the denominator of this power. So you see, we are now in order. So in that case, what do you do? From here, I'm going to have now 3 to the power of, if I raise this to the power of 3, this is what we have, multiply by this 1 over 9. I also multiply it by 1 over 3. Did we commit any error? Let's see. For this, look at what you have here. This is 3. When you multiply by 1 over 9, multiply by 1 over 3. See, this 3 will cancel 3. You'll be left with 3 to the power of 1 over 9, which is giving you back what you have. So if it gives you back what you have, it means you did not commit any blunder, okay? That means you are still in order. So in that case, we are accepting this. And you know from this point, it is equal to x to the power of 1 over x. So what do you do now? This is going to give us 3 to the power of 3 raised to power 1 over 9 multiply 1 over 3 is x to the power of 1 over x. So at this point, you have this has given us 27. 1 multiplies 1 is 1. This multiplies is 27. Is equal to x to the power of 1 over x. So you see now, this is the same with this, just like this is the same with this. So the equation is now balanced. So in that case, we conclude that our x is 27. And this becomes our answer. Now let's do a check. Let's know if what we did is still in order. So to do that, we are going to have x is 27. So we have 3 to the power of 27. Is it the same thing with 27 to the power of 9? We have 3 to the power of 27. Is it still the same thing with 27? You know is 3 to the power of 3. Then raised to the power of 9. Remember your rule of indices, which says a to the power of m to the power of n is a to the power of mn. You multiply the power when you bring it out from the bracket. So if you multiply this power, we're going to have 3 to the power of 27. Is it still the same with 3 to the power of, multiply this, you'll have 27. You see the left has become equal to the right. So in that case, we say they are equal, meaning that our answer is very correct. And I hope you learned a lot. If you did, let's know how much in the comment section and how you feel about this tutorial. It helps us to serve you best. Remember, you can share this tutorial with your friends and colleagues. Don't forget to subscribe for the more you get from us, and give this tutorial a thumbs up. I will see you in our next class to discuss more. Till then, bye-bye.